Good afternoon, everyone. Am I audible? Yes.
Yes.
Hello. Okay. I've not used the microphone now. Where we were last class. We were here. Okay. So what I was telling you. Okay. So where we were, this one, the pressure line method here. I told you that the stresses which are developed here in the when we are using the strength concept method, what are the stresses here now? The direct stress, which is the uniform stress C by A, that is nothing but your P by A. Then we have your, since this moment is in this way, your C line is below the CG of the beam. So the moment is in this way, that is the compression at the top and tension at the bottom. So plus minus, we have our CE by Z. Okay, so and I told you that the shift of the C line from the P line can be calculated by M by P. Okay, remove this. So the shift of the C line, this C line from the P line is given by how much? M by P, where M is the moment and your P is the pressure, pre-stressed force. Okay, so you can see here, if I go below, the same thing is written here. Okay, that means this when the C line will be shifted from the P line by a distance A called the lever arm. Okay, so the shift is given by M by P. In other words, we consider the shifting of the C line from the distance M by P. Now, corresponding to the new position of the C line and its eccentricity, the stress distribution for the concrete can be determined by this C by A plus minus CE by Z. This one, C by A plus minus CE by Z. Now, if we try to solve a question on, if we go down, E, so, okay. So see here, this is your question. Suppose we take now this question. What is happening? Pre-stress. What is the question? If we take this question, if a prestressed concrete beam 400 mm into 600 mm in the section has a span of 6 meter and is subjected to a uniformly distributed load of 16 kN per meter, including the self-weight of the beam, the prestressing tendons, which are located along the longitudinal centroidal axis, provide an effective prestressing force of 960 kilonewton. So determine the extreme stresses in concrete for midspan section. At the midspan, we are asked to calculate the stresses. So this particular question we will try to solve both in stress concept method and the strain concept method. Okay. So the basic things which we know is the area, the section modulus BD square by 6, and we know what is our moment. Due to this UDL, we have a moment of WL square by 8, which is 72 kilonewton. The pre-stressing force is also given to us 960, so 960 kilonewton. Now, when we try to solve this by our stress concept method, this one, stress concept method, what was our stress concept method? Here we have there is no eccentricity because it is said in the question that it is located along the longitudinal centroidal axis. Okay, along the longitudinal centroidal axis. That means at the center of the CG, your tendon is at the center coinciding with the CG of the beam. So we have no eccentricity. For the stress concept method I'm talking, there is no eccentricity. So we have how many stresses will be there? Stress, the direct stress, the direct stress P by A. Then we have our stress due to the bending moment due to the load, which is your this. Okay. M is 72 into 10 to the power 6, and we have our z this much. So our top stress which we have calculated is how much? Our top stress is 7. This was our total stress. And what is our top stress? Top stress is 7 Newton per mm square. Bottom stress is 1 Newton per mm square. Now what is our strain concept method? If we try to solve this particular question, uh, if we try to solve this particular question in the strength concept method, or you can say it is the C line method or the P line method or the pressure line method also you can say. Okay, so what we are going to do, our first step was what? We have to calculate these stresses. So we know that for stresses, what are the stresses? And we don't have any eccentricity here, but now we will have, because there is a load. This is the load is of 16 kilonewton per meter. So what we are going to do, we are first of all going to find out the shift of the C line from the P line. So you see here, if we solve this question, first of all, what we are finding out the distance of the C line from the P line, which will be shifting now due to this load and due to this moment. Okay, so that is given by M by P. We know moment is, we already know, pressure also we know. That means the C line moves 75 mm away from the P line. Okay, so you see here now, what is our eccentricity of the C line now from the CG? This was our, suppose this is the beam. We have the CG here, and we had what? We had the uh, this is our P line, you can say, because the CG as well as the P is on the same longitudinal centroidal axis. Now due to this loading, what will happen? The C line from the P line, it is going to shift, and at a distance of how much? M by P, that is 75 mm. So it is somewhere here, which is 75 mm. This one, 75 mm, and this is your C line. Okay, so now your eccentricity of the C line from the this was also your, this bottom one was also your CG of the beam. So CG of the beam and the CG of the, sorry, CG of the beam and the pressure line, sorry, the P line are coinciding here, but the C line has shifted, that is the compression line has shifted from the P line. So what will happen now? This is your eccentricity 75 mm from the CG, okay, not from P. But now since P is coinciding with C, that's why you may think that P, it is a eccentricity with the P. But mind it that your C line, we will find out the eccentricity of the C line with the CG, and this is your CG now according to this question, and also the P line now. So now the stresses at the mid span will be how much? We know it is a direct stress due to this P, that is C by A, the direct stress C by A, plus minus, since your eccentricity is here, and at the top your C line, since we are considering now the C line which is above the CG, so your movement will be this way. So it is plus compression at the top and the bottom minus, so plus minus CE by Z, that is the movement or the stress due to this eccentricity. Okay, so we got same, our total stress we got how much? 4 plus minus 3 Newton per mm square. So the stress at the top is how much? 7 Newton per mm square, and at the bottom we have 1, which is equal to this total stress at the top and at the bottom, and here also it is same, 7 Newton per mm square at the top and 1 Newton per mm square at the bottom. That means, what I mean to say is that whether you solve a question by stress concept method or by strain concept method or by load balancing method, your stresses developed will be same for both the top, bottom, or the entire stress you see. Okay, so understood this? The strain concept method, when your CG, there is no eccentricity of the tendon line, but then the C line has an eccentricity with the CG. Okay, fine. Is my voice clear to you all? Okay. So we have done this. Now if we take another question and practice on the strain concept method or the C line, P line, or the pressure line method, if we do this particular question, if we take this particular question, let me see one thing. Take this question here. This one, a pre-stressed concrete beam 400 mm into 600 mm in section has a span of 6 meter and is subjected to a uniformly distributed same load is there, 16 kN per meter self weight of the beam. The pre-stressing tendons are located at the lower third point and provided an effective pre-stressing force of 960 kN. So we know when we have a lower third point, that means your eccentricity is given to you. If this is your beam, this is your CG suppose. So your tendon is located at the lower third point. Let me erase this. So suppose this is your CG here, and now your tendon is at the lower third point. That means from the below, this is 600, 400 into 600. So this was 600. So half of here is 300, 300. So your tendon is here at a distance of, this is your P, that means, okay, and this distance is given to be 100 mm, which that means there is an eccentricity of the P line 100 mm. Now, try to solve this question by the strength concept method. I want to know the stresses at the top and at the bottom. We solve the question with the help of stress concept method. And tell me the answers. At the top stress, what are the top stress? What are your bottom stresses? Then we will also see the strength concept method. Hello? Hello? Hmm. Oh, एग्जाम ओवर हो गया? तुम सिविल का ही तो है? हाँ, तो कोई प्रॉब्लम नहीं है। एक मैकेनिकल का मतलब इंजीनियरिंग मैकेनिक्स। सब्जेक्ट कौन सा था? हाइड्रोलिक एंड हाइड्रोलिक मशीन। मैकेनिकल डिपार्टमेंट का तुमने क्यों दिया? एक मिनट है। Done, everyone? What is the answer? According to the stress concept method, if you have solved, what is the answer for the top stress and bottom stress? Anyone? Let me take the attendance till then. Enrollment 1,
Present, ma'am.
2, 4, 5, 6,
Yes, ma'am. Yes, ma'am.
5,
Present, ma'am.
5, 6.
And for
Yes, ma'am. 6.
Okay, 7,
Jordan.
8,
I'm for
Yes, Miss. Present.
8.
Number 8.
Okay, 9,
Present 8.
9. Hello? Hello? You solve this question. Try to solve this question. Actually, you are having the backlog examinations, and the students are having some problems on that. So I need to talk to some of the IT persons. So you try to solve this question. Okay, I'm just coming back, and I'll take your attendance after I come back. Yeah, what was the answer? Could you find the stresses? Direct stress method. With the help of direct stress method. Hello? Hello? Did you calculate it? Anyone? Or the stress concern method, the first beginning, how we had done, how we had solved the stresses without any eccentricity. But here we have an eccentricity. So within eccentricity, how you used to solve the direct stress at the midspan? P by A, and due to the load one stress, that is plus minus m by z. And when you have a tendon at the bottom, eccentricity is at the bottom, so you had minus plus pe by z. Top is 3, Stephanie Bang. Bottom is 5. Okay. Top is 3, bottom is 5. Okay, correct. So Stephanie got 3 top and bottom 5, and she is correct. Very good. She has tried. Okay, so we know this is our solution for the stress concept method. We know, okay, which is these are your these things you already know: area, section modulus, moment, P, eccentricity E, and so we know the total stresses will be how much? P by A plus minus M by Z minus plus PE by Z, and so the total stress comes out to be 4 minus plus 4 plus minus 3 Newton per mm square. So the top stress is 3 and the bottom stress is 5. Now the same question, if we try to solve by the strength concept method, what how is the solution? We know that we for the strength concept method we have to first of all calculate the distance of the C line from the P line, that how much your C line will be shifted to P line, right? So that it is given by how much? M by P. Okay, and that comes out to be how much here? 75 mm, this one. But now this time, wait, let me show you in figure. If we see, this is your beam, this is your beam. At the center, we have the CG, and we have at a distance of 100 mm we have P, the tendon. This is your P, the tendon, that is the P line is here. This is the CG. Now what is our shift of the C line from the P line? M by P, and that is 7, that comes out to be 75 mm. So that means from the P line your C line has moved 75 mm. Okay, so somewhere here is your C line, somewhere here is this is your C line. Okay, so this is your C line, right? So this portion is your 75. So now I told you that in the strength concern method we are concerned about the C line. So how much is the C line from the CG? We will consider that. And so once we know the shift of the C line from the P line, which is 75 mm, our eccentricity of the C line will be how much from the CG? This was 100, till the P it was 100, so 100 minus 75 will give you your this distance, which is nothing but the eccentricity of the C line from the CG of the beam. So it is 25 mm below the centroidal axis. Okay, so the extreme stresses will be how much now? The direct stress C by A, that means that is nothing but P by A. This one C by A minus plus CE by Z. Okay, your C line is below the CG, and therefore you have a moment of this way. So minus plus, that means at the top it is under tension due to this eccentricity, and at the bottom it is compression. So your total stress is now how much? 4 minus plus 1 Newton per mm square. So that gives your top stress to be 3 Newton per mm square and your bottom stress to be 5 Newton per mm square. So you can see that whether you do by stress concept method or you do by strain concept method, what happens is your total stresses are always same, whether it be at the top stress or the bottom stress. 3 Newton here also 3 Newton, 5 Newton at the bottom, here also 5 Newton. So this is your strain concept method where we consider the C line, okay, which is this effect of the C line, which is at an eccentricity from the CG. This gives the effect of the moment is shown by this C line. Okay, so this is the way how we proceed to solve the stresses in the strain concept method. Okay, difference between the stress concept and the strain concept method. If you go to another question, which is a question from band tendon, a precious concrete beam is placed with a tendon band as shown in the figure. The external load on the beam consists of a concentrated load of 180 kilonewton at the midspan. See, it has an external point load of 180 kilonewton at the midspan. It is the if the effective precision force is 1200 kilonewton, calculate the extreme stress in concrete for the midspan section. Okay, so this is your figure. We know we have already solved this type of problem, band triangular profile band tendon, which will have an upward pressure, upward thrust of 2 p sine theta. We know this thing. That was your load balancing method. Okay, this same thing now if we do by stress method, see this particular problem we will try to solve it by the three methods, which is your stress concept method, strength concept method, and the load balancing method. Okay, let me take these remaining attendance. Enrollment 9, 9, 10, 11, 12,
Present, ma'am. 12.
12, 14, 15,
14 present, ma'am. 14
15,
present.
15 present, ma'am. Present, ma'am.
17, 18, 19,
Yes, ma'am. 18.
okay, 18, 19, 20, 21, 23, 24, 25, 26, 27, 30, 31, 32, 34, 36,
34 present,
36 present, 26 present, 37,
Ma'am.
huh?
37 present, ma'am.
32, ma'am.
17 is
32.
present, 32 is present, 38, 36 present, 37, 38, 39, 42,
2
43,
present, ma'am.
42, 42,
Present, ma'am.
okay, 43, 44, 45, 46,
Present, ma'am. 45.
45, 48,
48
40,
present, miss.
49,
48
And
okay,
present, ma'am.
49,
49 present, ma'am.
okay. Then we have 50, 51, 52, 54,
Yes,
50,
ma'am.
54,
Present, ma'am.
okay, is present. Okay, 56, 57, 58, 59, 60, 61,
Present, ma'am. 60.
61,
60.
60, okay, 61, 62, 63, 99,
Yes,
Yes, ma'am, 99.
okay, 63 is present, huh?
yes, ma'am.
Okay. 101,
63.
101, 4, 106, 108.
Present, ma'am. 106.
108 present, ma'am.
Okay, 108 present.
106, ma'am.
106 present. 109.
109.
Okay, 111.
Acha beta. 109.
Yeah, yeah. 111.
Present, ma'am.
13. 14.
Ma'am, 109.
Yeah, present. 114. 114. Okay, 118. 118.
Present, ma'am. 118. Present, ma'am.
143. 144. 145. 148.
120. Present, ma'am.
120 present, ma'am.
120 present. Yeah, I gave.
120 present. Yeah,
113 is
yes.
present.
113 is present.
149.
149.
Not
124
present.
present, ma'am.
124 present.
133.
124 present, ma'am.
Okay, 124 present.
Okay, 124 present.
Oh, international Muslim, kenapa shift to Sweden?
34 present.
Okay. Okay, those who are left out, you can give in the this thing, the group. I'll give attendance to everybody. Don't worry. 143, 143. Okay, 133, 136, 133, 136. Okay.